So now we've started to learn about lists and tuples, and we need to be careful because those are a source of frequent confusion in Python. And that's why we have this lecture now. So the goal is to talk now about name binding and mutability, and two issues that we could ignore so far, but that we really need to learn about when we start dealing with lists in particular. Okay, so what happens when we make an assignment? Well, the answer is that we attach a name to a particular object, a Python object in the memory. That's all fine, but there might be other names that are already attached to the same object. So this can lead to confusion because you will have two names to refer to the same object. And you can start asking yourself, what happens when I modify one of the two names, or when I access via one of the two names that object and modify it? Is the object that I'm referring to by the other name also modified? To help you really understand all those issues, a tool was constructed called Python Tutor. So you can use it online, and it's used to interpret Python code and to show you what really happens and how Python really understands what's going on. So if you click on the slides, you'll get there, and I'll show you now how to use it. Okay, so we see here that we can start using online Python Tutor now. So let's click here, and there is some box where I'll delete everything, where we can enter some source code. And at the bottom, there is the option of visualizing execution. So let's enter some source code, and let's say x equals the list 1, 2, y equals the list 3, 4, and z equals x, let's say. And let's say we want to print x, y, and z. Okay, and we visualize execution. Now, we have some options to change and that we could change, but let's not do that for a second. And let's visualize execution. So what happens here? Well, on the left, we have our source code that has been integrated, if you want, in the Python Tutor. And here we see an arrow that indicates which line Python is about to read. And we can step one. So there are 4 lines if you want. So there are 4 steps, and we can go step by step. We can go forward 1 step, back 1 step, all the way to the last step, which amounts to running the whole program, or back to the first step, which amounts to starting over again. And on the right, we have some frames and objects. So ignore those names for a second, but let's go forward 1. So if we go forward 1, in the global frame, so if you want in the global context of the program, we have that the name x points to the object in memory, which is a list, and it consists of just 1 and 2. And 1 is in the 0th position and 2 is in the 1st position. And we go forward 1 step. So think about it. What do you expect to happen on the right? Well, if I go forward 1, I'll define a new variable x, a new variable named y, pointing to this object in memory, a list 3, 4, where 3 is at the 0th index and 4 is at the 1st index. Now here comes the important bit. What happens when I do z equals x? Okay, so if you think about it, there are 2 options. There are really 2 options, two things that could happen. So either you get a new line here. Well, definitely you will get a new line here because you will define a new variable name. Okay, so z will be here. Now the question is, what happens with the arrow? There should be an arrow pointing to a Python object. Now, the question is whether it will point to the same object that x is pointing to, or if a new object will be created here that will consist of the list 1, 2 again. So let's go forward. And we see that now z is pointing to the same object that x was pointing to. So when we print x, y, z, we'll get 1, 2, 3, 4, 1, 2. So when we start printing things, a new window will open here with the program output. So now we've been presented with Python Tutor, and I'll use this tool again and again in this lecture. And I really recommend you use it a lot for your own sake, just on your own on the side, to really understand what Python does with different variable assignments and different things that you might manipulate. Okay, there were some options, and one of them was to render all objects on the heap instead of the option inline primitives and nested objects. So I recommend you use that option sometimes when you want extreme consistency in the way Python tutor will present things. So the render all objects on the heap, that way is more consistent than the other one, but the other one produces simpler diagrams that might be easier to understand. So maybe you try using first inline primitives and nested objects to understand what's going on, and if that doesn't work, then you go to the more consistent approach that might make more sense for your particular problem. Okay, so this whole lecture was about name binding and mutability. So how does Python tutor help us? Well, let's see an example here. So we have a little program where we assign to A, B, and C the values 1, 1, and 2. And then we assign to D the value of A, basically. And we add to A the value 5. Now what happens? So let's run it. Let's see in the Python tutor what happens when I run it. So I have now my code on the left, and I start running step by step. So now I have a new variable A, and I've assigned to that variable name the value 1, the object 1. And B points to the same object because it's the object 1 in memory. Now C is assigned the value 2, and D will be assigned the same value that A is assigned to. So D suddenly also points to 1. Okay, so you can see it on the right. D is pointing to the same location. And now I add to A the value 5. So what happens here? Well, the object that A is pointing to is taken. I add the value 5, and I reassign that to A. So A now points to 6 because I've taken the value 1, added 5 to it, that became the value 6, and I assigned A to A the value 6. I didn't change the value of B or D because I haven't changed the object that B or D are pointing to. And if I print, I get 6, 1, 2, 1. So that might be a very natural behavior for you. You might think that's completely normal. So let's see how this translates in the next for the next examples. So here is the next example. Now I take strings. I take the strings 1, the string 1, the string 2, and I add the string 5. And adding means for strings means concatenating, adding them one after the other, so joining them if you want. So let's run this code and let's see what happens. So I have the string 1, I have the string 1 again, I have the string 2, I assign to D the value as value the object that A is pointing to, so D is pointing also to 1, and then I take the value that A is pointing to and I concatenate this with the string 5, and I reassign this to A. So think about it, what should happen? There is some ordering problem here as well, and what happens is that A is now assigned 15. So if I print, I get 15, 1, 2, 1. That's perfectly logical. Now let's look at the next example. The next example is here with now lists. So it's the same thing, but we're now using lists. So if I run it, I have now that the list 1, I can go forward again, the list 1, and I've decided to render all objects on the heap, so I'm pointing to 1 here, right? I don't have a list with just 1. I'm distinguishing between the object list and the object int here. So there is internal links if you want. And B is now pointing, you don't see it, but it's pointing all the way there. So it's pointing to the same object. C is now pointing to a new object, which is 2. Okay? And D is now pointing to the same object that A is pointing to. And now I take the list A and I add to it the list just 5 on its own. And adding lists means adjoining them. So adding to it means you just concatenate the lists again. So you make a list that's bigger, consisting of the union of the two parts in order. So if I add now, this is the new list A, and the first part is pointing to 1, that hasn't changed, but the second part is pointing to 5, okay? Because I've created an intermediate list, and now I've added those two lists together, the original one for A and the new temporary list 5. And then I decide to print. And if I print, I get 1, 5, 1, 2, 1. So this behavior is again very similar to what was happening with the strings. And yeah, indeed, it's exactly the same behavior. So let's see the next example. And the next example is now with, so let's compare. Instead of here taking A equals A plus 5, I've now taken A plus equal 5. And let's run it. So if I run it, I get 1 that hasn't changed. I get 1 that hasn't changed. C pointing to 2 that hasn't changed. D I'm assigning all the way there. And here is the main difference. So I'll still construct an intermediate list consisting of just 5. But the main difference here is that I'm not taking the object A and adding 5 to it and then reassigning this to 5. What I'm doing with this plus equal is adding at the end of the object that A is pointing to the list 5. And when I do this, you will see that I modify here the object that A is pointing to so that it has one more entry that's pointing to 5. But the catch is D is also pointing to the same object. So when I decide to print now, I print and I realize that unlike before, D has also been changed. Okay, so this is the main difference that I wanted to emphasize with the lists and augmented assignment, this plus equal, and what happened there. So let's go back to the slides and let's try to understand what happened. This different behavior comes from mutability and immutability. So in Python, objects are either mutable or immutable. Immutable objects can never be modified. They are created in memory and then they are kept forever and they cannot be changed. So examples would include ints, strings, floats, longs, and tuples, for instance. So once you have created the object, you can't change it. That's very important. And this explains the behaviors before, that if I took an integer and added 5 to it, I'm not modifying the original integer. I have to create a new integer and then assign A to that new integer. And thereby, I'm not changing D, which was pointing to the same object as A. Okay? So really, if you want to modify a mutable object, you can't. An immutable object, sorry, you cannot. You're not allowed to do that. You have to create a new object and bind your variable to that new object. Of course, the contrast is mutable objects, which can be changed. And as we saw, this leads to unintended behavior sometimes, or at least behavior that might be unexpected and might lead to bug. And in particular, this happens when several variable names bind to the same object. And this happens, and this is called aliasing. So before I was aliasing A and B, I was making them point to the same object. And in some cases, for instance, when I have a list, then it's mutable. I can modify the object that A is pointing to, and this happens to also be the object that D is pointing to. So in effect, the value of D has also changed. So I suggest you go back through the examples and work through them, and maybe this will make more sense with this little explanation of mutability and immutability. Well, naturally, for mutable objects, we have to distinguish between functions that act on those objects. Some of them will modify the original object, and some of them won't. So, for instance, plus equal, the augmented assignment, append, insert, and reverse are examples of functions or methods that will have side effects, or operators actually, that will have side effects, that will modify the original object. So to illustrate this, I've concocted a little example where I have some augmented assignment, I have appended some stuff, I have inserted, and I've done a reverse. And you should think a little bit about what this program will do and try to predict what the output here will be at the end. and also here. So let's run this example and let's see what happens. So if I run this example, I see that A is equal to 1, so I've now A pointing to a list, and B points to a list as well. And then I'll do a series of modifications of A, and all those modifications will actually change, will have side effects, will change the mutable objects, the mutable object that A was pointing to. But this object also happened to be the object that B was pointing to, so in effect, the value of B is also changing. So let's see that. Now I've added another little sequence, another list to A, or to the object that A was pointing to. So now A and B both point to a list of length 2. And I append another value, I insert yet another value, and I reverse the whole thing. And now I decide to print AB, and A and B still point to the same object, so I'll have twice the same thing. Now, at step 8 here, I do something different. I take the object that A is pointing to, I add to it 0. So I'm creating a new object actually here, and I'm assigning to A, I'm binding A to this new object. So in other words, I've changed what A is pointing to, and now A is pointing to a completely new object. I haven't changed what B is pointing to. So on the right here, you'll see that B still points to the same thing, and A will point to a completely new object. And you see this. A points to a completely new object, and this is a new list. And it happens that this new list points to the same objects that the original list was pointing to, but now I have a new list. And so if I print, if I go to the last step and I print, I see that A and B don't actually print the same thing. I know it can be extremely confusing, and actually I've only touched the surface of how confusing this can be. So we'll run a few more examples and we'll see there truly very confusing situations. And really, I think the Python tutor is a great tool to help you understand what happens there. So I cannot recommend it more highly that you actually use Python tutor and that you try to figure out your bugs or the sample programs that I've prepared. You try to figure out what's going on with Python tutor in those situations.